So, before we actually step out and do today's lesson, before that, I want to go through today's quiz and make sure we know what the heck we're doing when we hit tomorrow. And like I said, I think that these questions are pretty easy. And I'm also going to tell you a story about my son Jimmy. Miss Avicillis, if you could hit the lights, please. Thank you. Okay, so when my son Jimmy was in 8th grade, he had to take a state test, kind of like you guys. But the one difference is that you could not opt out back then. So he had to take the test. And he did. And he got one question wrong. And this was it. This is the question that my son Jimmy got wrong. So the next time he subs for you, you can look at him and go, I know the question you got wrong on your 8th grade test. And he put the same wrong answer most of you put. Most of you who got number 1 wrong, you all put you put 10. That's what he would have put, the way he did it. And it's wrong. Listen. Little is to big, as little is to big. Little is to big, as little is to big. You want the rap version? A little is too big, as a little is too big. Little is too big, as a little is too big. Heavy metal version?
Yeah.
I just don't have the hair long enough to fly around when I'm doing that. But the bottom line is, whichever version you want, or the country version, little is too big, as little is too big. My dog done died and my wife left me. Think I'll have a bear. Okay. Now, little is too big as little is too big. Little triangle, side that corresponds. Remember we talked about that word corresponds? Anybody remember what corresponds means? Matches up with. Everybody say corresponds.
Corresponds.
That's stuck. Corresponds.
Corresponds.
Matches up with. All right, Miss Romero, Miss Saltu, look here. You see how the 8 matches up with the 12? So in my little is to big, I go 8 is to 12. Now, the 6 matches up with what? The n. 6 is to n. Cross multiply. 8 times n is 8n. 6 times 12 is 72. Don't forget, a couple of you guys did all of this beautiful work and then you forgot to divide by 8. 72 divided by 8 is? 9. And 9 is the right answer. Now, I knows what you guys who put 10 done did. And we do not want to done do that no more. Ready? You guys went like this. I add 4 here. So what am I going to do here? No way, Jose. 2es muy malo. All right? That means you're very bad. Shame, shame, shame. No bueno if you got un 10.
What?
You're not good if you got 10.
Oh, I heard DS. So.
Now, every time you see this problem, you guys need to start singing whatever version of that song you want to sing. You want to sing the country version? Little is the bike, as little is the bike. My dog done died and my wife left me. You could do that version. You could do the heavy metal version. I don't want you screaming in the middle of class. You could do the rap version. Or you can do the pop version. Little is too big, as little is too big. Spencer, you love that version, don't you? Now, listen, no one in this class can convince me that that's hard. It's easy. The whole trick, listen, the whole trick is recognizing, oh yeah, I gotta write little is to big as little is to big. As soon as I write that, the problem follows. Okay, now, speaking of not convincing me that this is hard, or whatever I want to say here, yeah. This is not hard too. Let me put my little old man glasses on here. You know, I'm almost retired.
Me too.
2, 4,
I got
6,
6 more years.
8, 14. You only have 53 to go.
Oh, yeah.
Yeah. Usually you retire at 65. Usually.
I don't know if it's cool.
But if for school. Yeah, for teaching, you normally retire at 55. If you started when you're young, which I did. I started when I was 22. I was a baby.
Okay, where you are.
I actually had 2 different girls invite me to parties when I was there teaching. Very, very strange.
Whoa.
At 22 years old, I was like, no.
Why did you go?
I think the answer's pretty obvious to that one. Okay.
I would have went.
Oh yeah?
I would. Okay, how old were they?
Then you'd have gotten fired. They were in high school.
Oh, bro. High school.
No. That's why, like, kids come up to me and they go, Miss Lindquist, would you be my friend on Facebook? And I tell them the same thing every single time. When you graduate, I'll friend you on Facebook. Not until you graduate.
Well, high school.
High school.
What about when you
Oh.
retire?
Bro, you said you
When
get
that's, you know
tired.
what, one of the kids looked at me, because that's how close it's getting. And she said, oh, wait a minute, you're retiring in 2 years. That's before I'm out of high school. I said, you know what, if I retire, you can friend me. Yes,
I'll
If I
friend
don't
you.
graduate high school.
you better.
No, but just saying. What
Remember
am I
that
doing?
statistic I gave you about poverty? So we don't consider the possibility of not graduating high school. You will graduate high school, and you will make a really good life for yourself. Are we clear on that? Okay. Now, next, what is the rate of change? Guys, what's another word for rate of change? Hey, pay attention. You've been doing much better lately. Don't get distracted now. God bless. What is another word for rate of change? No, come on. Slope, very good. And slope is known as change in y over change in x. Now, let's take a look at this table. What am I going up by here? 4. What am I going up by here? 2. Now, some people put the answer 2 over 4. What's wrong with that answer? Obviously, why is it not right? Because what? Yeah, if you did 2/4, you reversed it. You did the reciprocal. It's supposed to be the change in what? Y. Here's the y's. What are the y's going up by? 4. What is the x going up by? 2. And 4 over 2 is 2. So you could write 2 or 2 over 1. You could even write 4 over 2. All of those are good. So that's what the rate of change is. The next one says, write the function rule. Function rule is in the format of y equals mx plus b. And most, oh, by the way, some people, for rate of change, wrote like this. No way. It's always a fraction. Okay? Don't forget that. Next. Y equals mx plus b. The good news is most people did indeed tend to write it in that format. And a lot of you got this right, which was very good because we have been working on this right before the break. So it's going to be y equals, now what does m stand for? Slope. Good. Well, what did we just say the slope was? Yeah, but what did we figure out the number to be? 4 over 2, which is 2. So y equals 2x. How do I find the b? Steven, how do I find the b, everybody? Come on, you should know this. Kayla? Oh, did you say go down 4? Yeah, I hear very poor. I've been married for 30 years. The hearing's shot. Now, look, Kayla's exactly right. Follow the pattern. There is no 0. We want to know what's paired up with 0, but there is no 0. So she goes 8, 6, 4, 2. What goes next? 0. And then she said go down 4. Down 4, down 4, down 4. What's 5 minus 4? 1. So therefore, it's y equals 2x plus 1. Okay? And that is my function rule. Now I got to ask you a question. Tell me the truth, the whole truth, nothing but the truth, so help you.
Okay.
Is this hard?
No.
I don't think so. So if you made mistakes, that's okay, as long as you learn from them, and then you do really well on tomorrow's quiz. Now the last one says, what value should be placed in the box? Well, this box is the y when the x is 14. So you gotta plug the 14 in for x. So you do 2 times, because no symbol means multiply, 14 plus 1. What's 2 times 14? 28. And what's 28 plus 1? Now there is no way you can convince me that that's a hard quiz. And I think the reason that those people who got questions wrong got them wrong is because not that what you had to do was hard, but I think they were unsure of what to do. Does that make sense? Okay, so tomorrow you know the drill. You're going to get the same quiz with the numbers changed. It's going to have a table. It's going to have 2 triangles. It's going to have the same questions. What's the rate of change? What's the function rule? And what value goes in the empty box? Okay, so we are on our second day of the Pythagorean theorem. And what we learned yesterday is that the Pythagoreans were quite the crowd. They liked to party, but their kind of partying was much better than the current state of partying. Nowadays, when we talk about partying, we talk about getting so out of our minds that nothing good comes from it. But back in the days of Pythagoras, they would get together and have parties, but when they would have those parties, they would make it a point to do math as a search for truth, permanent, eternal, never-ending truth. I would say the American way, except back then it was the Greek way. Now, let's verify indeed that the Pythagorean theorem works. This is what we did yesterday, and I will do it very quickly because we already did it in class. Remember yesterday I put this symbol here? Does anybody remember what that symbol means? Right angle, very good. And then I draw a cross, and what is the side that's across from the right angle? Everybody? Hypotenuse, very good. As if you look at that word, I don't know how much you know about languages, but that word just looks Greek. Did you ever hear the expression "that's Greek to me"? Anybody ever hear that? When somebody says something to you that you don't understand, they'll look at you and go, "Sounds like Greek to me," because it just sounds so foreign and so weird. And Greek is a very strange language compared to English. Oh, big time. And it's also a better language. It's very exact in what it means. I'll give you for instance. How many words in English do we have for the word love? 1. Love. It is. It's one word, love. And the truth is that there are many different contexts that we can use the word love in the English language. In fact, there are 4 common contexts for the word love in the English language. For instance, one of them is what the Greeks would have a word, storges. Storges. Tell you in a second. Storges is this kind of love that's built into human beings that we all have, but it's its own unique kind of love. And the kind of love that storges love is like, isn't it like if someone gives you a puppy, don't you love them instantly? Aren't you like, oh, what a cute puppy, I love him. Or you get a kitty cat, and you're like, oh, what an adorable kitten. Or okay, you feel strongly about that. Or maybe you love your favorite soccer team or your baseball team or whatever team. That's storges. Storges is a different kind of love. Now the second kind of love is phileo. Now you've heard of Philadelphia, the city of brotherly love. Phileo is a love that you would have for like mankind. Okay? Just a love that we would have one for another. I would like to think that we would all sacrifice for each other. I would like to think that the well-being of all of us is important to all of us. That's phileo, that's that kind of love. Okay? An example of that might be, I love the guys on my wrestling team. I love, or another example of storges might be, I love teaching. Okay? Some kids might say, I love learning. So those are clearly 2 different kinds of love. I don't love the guys I go fly fishing with the same way I love learning. It's a completely different kind of love. Yet in the English language, we only have one word. Now, a third kind of love in the Greek language is the word eros. And eros is the kind of love like a husband and a wife have for each other. Okay, love between the sexes. And the fourth type is the word agape. Agape is a sacrificial love.
That's scary.
Well, no, what I mean by that is this. A sacrificial love would be a love like as follows. Didn't I tell you a story about when I used to walk to school with holes in my shoes?
Yeah, no.
Okay. Yeah, very, very short, because I don't want to waste a lot of time here, but I remember my dad saying one time, or my mom saying to me, Bobby, do you love, I mean, really love this girl the way your father and I love each other? And at the time, she was talking about my wife, Sue, who at the time was my fiance, and I had put the wedding off 4 times. And before, well, it was a matter of money. We simply didn't have the money to do it. So before I could answer about how much I love Sue, my dad cut me off, and he said to my mom, of course not. And I was like, what the heck? Who are you to answer that for me? And my dad followed that up even before I could even say that word. And he said, they haven't been through the death of a parent together. They haven't been through sweating rent together and a mortgage. And then my dad said these words. He said, he hasn't had to walk to work with holes in his shoes, or go to work with holes in his shoes, so that his kids could have diapers, or so that his kids could have something to eat. And I remember, like, I always have something to say, and I was just dumbfounded quiet. So, a few years later, my wife and I had kids. I lived about 3.5 miles away toward Belport. And we only had enough money for 1 car, and the car went to my wife. I used to walk to school, and I had I remember my left shoe having a hole. I don't remember my right shoe having a hole, but maybe it did. A hole in my left shoe. And every day that it would rain, and I would walk 3.5 miles from my house to school, and I would get to school, the water would seep through the bottom of my shoe, right through the wintertime. And it took me about an hour to walk 3.5 miles. And every step I would take in the hall, you would hear my shoes squishing. And it was humiliating, it was embarrassing. But I had no choice. I could not afford a pair of shoes. I needed to make sure that my children had diapers. I needed to make sure that my children had something to eat. I needed to make sure that my wife had a car that if God forbid an emergency happened with my children, she could throw them in the car and get them to the hospital. That's sacrificial love. That's agape kind of love. So the Greek language is far more exact than the English language, okay? Now, this word hypotenuse, to look at it, you just look at that word and it automatically oozes that it's Greek. And you'll learn more about that as you learn more about the English language. Now, if this Pythagorean theorem is true, I can put these numbers into this formula and it'll work. So if 5 is the hypotenuse, then 3 and 4 are the legs. So does 3 squared plus 4 squared equal 5 squared? And that's 9 plus 16 is 25. 9 plus 16 is 25. 25 equals 25. Check. Yes, the Pythagorean theorem works. Now, that's not an absolute and a complete proof, but it's a really good idea that it's going to end up working, and for our purposes, that's good enough, okay? So, yesterday, we started to do some work where we actually found n in the diagram. So let's try the first diagram with the 6, the 9, and the n. Go ahead. Give it a shot. Let's see how you do. Again, we did questions just like this yesterday, so you should be pretty comfortable with it. Okay, so. Years ago. Well, let's talk about current day. There's a director of math right now by the name of Mr. Soho, who's awesome. He's fantastic. Now, before him, we had a director of math named Mrs. Stegman. Not so good. And I remember disagreeing with her on so many things. But there's one thing she taught me that I will never forget that was so helpful. She said that they did a study with Pythagorean theorem questions, and they found that if the students did the following, they almost always got it right. And if they didn't, they far more frequently got it wrong. This is the little thing that they had to do. I showed it to you already. Draw the right angle, draw the line across. If you just do that, then you will remember what side is the hypotenuse. And then we write leg squared plus leg squared equals hypotenuse squared. One leg is 6, one leg is 9. I was going to square it in my head. And then the hypotenuse. So that makes 36 plus 81 is n squared. Same side, same operation. 117 equals n squared. And now we have a problem. Big time problem. The problem is this. When I go to square root both sides, I'm going to get a very ugly answer. On your calculator, type in the square root of 117. And this is exactly why we have you using calculators, because of this question. Okay? Did you notice how you get a very big ugly decimal?
Yeah.
Okay.
Rounded.
So, we're gonna round it to the nearest hundredth, which is 2 decimal places. So, it's gonna be 10 point something, 10 point what? Give me the first 3 numbers.
8, 1, 6.
816. Now I'm gonna round that off, okay? I'm gonna round to the nearest hundredth. This is the hundredth place. 6 says goes up, 10.82. Okay? Make sense? Everybody with me on that? Okay, you try the middle one. Go ahead. Sometimes they don't need to be rounded off, sometimes they do. Okay, now, remember, the one good thing Mrs. Stegman taught me. Draw the right angle, draw the arrow, n is the what? N is the what? Hypotenuse, good. So, 9 squared plus 12 squared equals n squared. 81 plus 144 equals n squared. Same side. Add them up, 225 equals n squared. Square root. Square root of 225 is 15. So n is equal to 15. Right? So, sometimes it's a whole number, sometimes it's a decimal. There are no guarantees. Okay, now let's take a look at this one. Draw your right angle, draw the arrow, and then I just want you to write, follow me, look at me, don't look down, Selena. I want you to write leg squared plus leg squared is hypotenuse squared, then I want you to fill in the numbers, then I want you to stop. Okay? So I'll give you about 45 seconds to get that done, then I'll put them up. when this one's done. Okay, ready? Ethan, head up, bud. We know it's your right triangle, so we know we're gonna use Pythagorean theorem. So I write it. Leg squared plus leg squared is hypotenuse squared. Again, sometimes they say a squared plus b squared is c squared. It's the same thing, as long as c is the hypotenuse. Now, here's my right angle. Here is my hypotenuse. So it's n squared plus 10 squared equals 14 squared. Now, solve that. Go ahead. All right, folks. Hasta la vista. Vaya con Dios. I lost track of time there.